Hi, my name is Mark Kroells. I'm with TÜV Rheinland. I'm the field service manager here in the Caledonia office. Today we're going to be talking about phased array ultrasonics. One of the benefits of phased array ultrasonics that we can see here is you can actually receive a permanent record of the scan. As you can see at the baseline, this is called a C-scan of the weld examination. Indications are represented here with the color scale that represents the amplitude or the size of the defect. As you can see, what we're doing is sending sound in from multiple angles, from 45 degrees up here all the way down to 70 degrees, or from 45 down here to 70 degrees on the top. This scan is completed with a one-time scan. The transducer, comparative to single element transducers, has up to 64 elements. We can fire those groups of 16 elements to shoot through different areas of the weld simultaneously at one location or one offset from the center line of the weld. If you look on here, we have a scan plan which demonstrates the sound exiting the rear of the transducer and reflecting off the baseline and shooting into the middle quadrant of the weld. The red line is the sound that is exiting off the front of the transducer, still going in with multiple angles, shooting directly to the root of the weld. So in one scan, we can scan a weld, pipeline weld, long seam, and we can gather all the data. The data is then stored in an image like this. We have multiple displays that we can pull up the display and review the data. As you can see here, we have an indication down here, which is representative by this, at that angle. This indication is being seen here. As we adjust the angle, we can obviously increase or decrease the amplitude or the indication that we're there. So with this tool here, we can dial through from our 45-degree angle, which is being represented here, which is showing us the whole plate, what's being detected with our 45-degree. And as we scan through our angles up through 70 degrees, we can see how the image changes and the amount of indications that are seen with different angles. We have a suspect location. We can zoom into it or dial in to that area that we may see here, and this is our scan data, so we can roll through our scanning and represent the indication that we see. As you can see, it's on this right here. If we go into this angle, can dial that back down so can maximize the angle. So at a 52-degree angle, we're getting a high response, which is showing the indication in the weld right at the cap of the weld on the far side. So the sound bounces down through this angle up to the top of the weld, and this shaded area is representative of the top of the weld.
So compared to other providers, what's the benefit of this?
Benefit is the speed in which you can do this. This can be all scanned in one scan. It's all saved. It's comparative to X-ray, but you can work alongside the welder at this application. You don't have to be a distance away, so it eliminates the lag time or shooting off shift, or eliminates the lag in production. From if we do find a defect, we can mark it out, and the welder can be right there with us, repair it, and we can go ahead and back scan it and verify that the indication has been removed, therefore speeding up production and keeping things moving.
Good, so that's excellent.
All right, thank you.
Thank you so much.